we now discuss the solution of a problem from the section Binomial Theorem. The problem is related to the ratio of two terms of a given binomial expansion. This question has appeared in the joint entrance examination main held on 6th April 2023 in the first shift. The given question is, if the ratio of the fifth term from the beginning to the fifth term from the end in the expansion of fourth root of 2 plus 1 by fourth root of 3 whole power n is square root of 6 is to 1. Then the third term from the beginning is, we are given four options. Option 1, option 2, option 3, option 4. We are given the expansion of fourth root of 2 plus 1 by fourth root of 3 whole power n, and it is given the ratio of the fifth term from the beginning to the fifth term from the end in this expansion is given to be root 6 is to 1. Then required to find the third term from the beginning of this expansion. We now discuss the solution of the problem in detail. Now, this is the binomial expansion, and in this, the fifth term from the beginning in this expansion, that is fourth root of 2 plus 1 by fourth root of 3 whole to the power of n. The fifth term is given by term capital T suffix 4 plus 1, that is the fifth term, is equal to NC4 into fourth root of 2 to the power of n minus 4 multiplied by 1 by fourth root of 3 to the power of 4. Yes, you remember what is the formula for the Tn plus 1. Right. Tr plus 1. Tr plus 1, not n plus 1. Tr plus 1, r is equal to 4. And so that will be NCr into x to the power of n minus r into a power r. Here x is fourth root of 2, a is 1 by fourth root of 3. Agreed. Now, T prime 4 plus 1 is the fifth term from the end of this above expansion. Right. So, let's recall this result. R plus 1th term from the end in the expansion x plus a to the power of n is equal to R plus 1th term from the beginning in this expansion a plus x to the power of n. So the fifth term in this expansion is equal to the fifth term from the beginning in the expansion of 1 by fourth root of 3 plus fourth root of 2 to the power of n. Agreed? Agreed. And that will be equal to NC4 into 1 by fourth root of 3 to the power of n minus 4 multiplied by the fourth root of 2 to the power of 4. Agreed. Agreed. And now it is given T4 plus 1, fifth term from the beginning by the fifth term from the end is equal to root 6 by 1. That is equal to, simply substitute these values, NC4, fourth root of 2 to the power of n minus 4 into 1 by fourth root of 3 to the power of 4 by NC4 into 1 by 4th root of 3 to the power of n minus 4 into 4th root of 2 to the power of 4 is equal to root 6. NC4 cancels, and we work out here and find out the value of n. That is what we do in the next slide. So we have this one, that is, the ratio is root 6. NC4 cancels. 4th root of 2 to the power of n minus 4 by the 4th root of 2 to the power of 4. When you bring it to the numerator, it is 4th root of 2 to the power of minus 4, and then it becomes 4th root of 2 to the power of n minus 4 minus 4, that is n minus 8. So also, if you bring this one, 1 by 4th root of 3 to the power of 4 to the denominator, in the denominator it will become 1 by 4th root of 3 to the power of n minus 4 minus 4. That is, the 4th root of 2 to the power of n minus 8 by 1 by 4th root of 3 to the power of n minus 8 is equal to root 6. Now, the 4th root of 2 to the power of n minus 8, and this will come up. This will come up 1 by this one. Therefore, the 4th root of 3 to the power of n minus 8. The powers are same. The 4th root of 2 multiplied by 4th root of 3 is 4th root of 6 to the power of n minus 8 is equal to square root of 2, square root of 6. That is equal to 6 to the power of n minus 8 by 4 is equal to square root of 6 is 6 to the power of 1 by 2. The bases are equal, therefore the powers are equal. So n minus 8 by 4 is equal to 1 by 2. That will imply n minus 8 is equal to 2, cross multiply, right? So n is equal to 10. N minus 8 is equal to will imply n is equal to 10. So now n value we know, and required to find the third term from the beginning in this expansion, that is the 4th root of 2 plus 1 by 4th root of 3 to the power of n is 10. And that is equal to t2 plus 1. T2 plus 1 is equal to 10c2 into 4th root of 2 to the power of 10 minus 2, yes, 1 by 4th root of 3 square to the power of 2. And that will be equal to 10c2 is 10 into 5 by factorial 2, that is 45. This is 2 to the power of 10 minus 2, 8 by 4, that is 2 square, and this is 1 by root 3 only after making the square of it, this one. So that will be equal to 45 into 4, 180 by root 3. This is equal to 60 root 3. Let's look at our options. Our answer appears against option 2. Therefore, the answer for this question is option 2. So the answer to this question is option 2. That is the detailed discussion of the solution of the problem, which is from the section Binomial Theorem. And it is definitely an easy question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.